Good morning. Myself, Dr.B.Saritha, Associate Professor, Department of Civil Engineering. Course name is Water and Sewage Conveyance. And the topic which I am going to discuss is Principles of Hydraulics. Under Principles of Hydraulics, we are going to see about the basic concepts, properties of fluid, types of fluid flows, energy losses in pipes. Under energy losses in pipes, we are going to see major energy loss and minor energy loss. In basic concepts, we are going to see the definition. Like mechanics, it is one of the oldest physical science which deals with both stationary and moving boundaries under the influence of various forces. So this branch of mechanics, it deals with the bodies which are at rest. So this is called as statics, while the branch that deals with bodies in motion is called as dynamics. So here in this branch of mechanics, we have two classifications, that is statics and dynamics. So statics deals with the bodies which are at rest, whereas the dynamics deals with the bodies which are in motion. Fluid mechanics is the science that deals with the behavior of fluids which are at rest, which is otherwise called as fluid statics, and the fluids which are in motion, which is called as fluid dynamics, and the interaction of the fluids with solids or other fluids at the boundaries. Next topic is the properties of fluids. So any characteristics of any system or the thing is called as property. So it may be either intensive or extensive. So intensive means it is mass independent, and extensive means it depends on the size of the system. So the properties, it may be either intensive or extensive, and the state of the system is described by its properties. So the number of properties which is required to fix the state of the system is given by the state postulates, and we can see the properties of the fluids one by one. The properties of fluid. First one is pressure. So under pressure, we are going to see the definition. So pressure is the normal force exerted by a fluid per unit area. So in SI system, the unit of pressure can be written as Newton per meter square. And the next property of the fluid is density. The density of the substance is the quantity of matter which is contained in unit volume of the substance. This density can be expressed in three different ways, that is mass density, specific weight, then relative density or specific gravity. So density is defined as the quantity of matter contained in unit volume of the substance. The next property is the temperature. Temperature is the measure of hardness and coldness of a system. So in thermodynamic sense, this is the measure of internal energy of a system. So many a times the temperature is expressed in degrees Celsius, that is in centigrade scale, where the freezing and boiling point of the water is taken as 0 degrees Celsius and 100 degrees Celsius. Whereas in XI system, the temperature is expressed in terms of absolute value, that is in Kelvin scale. So Kelvin scale, that is equal to degrees Celsius plus 273. To convert to Kelvin, centigrade plus 273. The next property of the fluid is viscosity. When two solid bodies in contact move relative to each other, a frictional force develops at the contact surface, so which is in direction opposite to the motion. So this situation is similar when a fluid moves relative to a solid, or when two fluids move relative to each other. The property that represents the internal resistance of a fluid to motion is called as viscosity. So the property which represents the internal resistance of the fluid to motion, that is fluidity, is called as viscosity. In general, the viscosity of the fluid mainly depends on temperature. So the temperature plays a vital role in deciding the viscosity of the fluid. So for liquids, the viscosity decreases with temperature, and for gases, it increases with temperature. Then the next property of fluid is specific heat. It is the amount of energy required for unit mass of a fluid for unit rise in temperature. Since the pressure, temperature and density of a gas are interrelated, the amount of heat required to raise the temperature from T1 to T2, it depends on whether the gas is allowed to expand during the process, so that the energy supplied is used in doing the work instead of raising the temperature. So this is about the specific heat, which is one of the property of the fluid. Then the next property of fluid is vapor pressure. Vapor pressure is defined as the pressure exerted by its vapor in phase equilibrium with its liquid at a given temperature. For a pure substance, it is same as the saturation pressure. In a fluid motion, if the pressure at some location is lower than the vapor pressure, bubbles starts forming. So this phenomenon is called as cavitation, because they form cavities in the liquid. So this is about vapor pressure. Vapor pressure is defined as the pressure exerted by its vapor in phase equilibrium with its liquid at given temperature. Then next property of fluid is surface tension. When a liquid and gas or any two immiscible liquids are in contact, an unbalanced force is developed at the interface, which is stretched over the entire fluid mass. The intensity of molecular attraction per unit length along any line in the surface is called as surface tension. So this is called surface tension. That is surface tension when a liquid or and gas or any two immiscible liquids are in contact, an unbalanced force is developed at the interface, which is stretched over the entire fluid mass. So the intensity of the molecular attraction. So we can define the surface tension as the intensity of molecular attraction per unit length along any line in the surface. So this is called surface tension. The next topic will be types of fluid flows. First one is viscous and inviscid flow. That is the fluid flow in which frictional effects become significant. They are treated as viscous flow. When two fluid layers move relatively to each other, frictional force develops between them, which is quantified by the fluid property called viscosity. So boundary layer flows are the best example for viscous flow. When neglecting the viscous terms in the governing equation, the flow can be treated as inviscid flow. So viscous and inviscid flow. Then the next type of fluid flow is internal flow and external flow. The flow of an unbounded fluid over a surface is treated as external flow. And if the fluid is completely bounded by the surface, then it is called as internal flow. For example, flow over a flat plate is considered as external flow, and flow through a pipe or duct is internal flow. So flow over a flat plate is called as external flow, and flow through a pipe or duct is called as internal flow. However, in special cases, if the duct is partially filled and there is free surface, then it is called as open channel flow. Internal flows are dominated by viscosity, whereas the viscous effects are limited to boundary layers in the solid surface for external flows. So this is about internal and external flow. So internal flow, best example is the flow in the pipe or duct, and external flow is the flow fluid over flat plate. Then next type of fluid flow is compressible and incompressible flow. The flow is said to be incompressible if the density remains constant throughout the flow. And when the density variation is there, and if it is more than 5%, then it is treated as incompressible flow. So incompressible flow is the density remains constant throughout the flow, whereas if the density varies, that is if the variation is more than 5%, then it is called as compressible flow. Then next type of fluid flow is laminar and turbulent flow. The highly ordered fluid flow characterized by smooth layers of fluid is called laminar flow. That is flow of highly viscous fluids at very low velocity is called as laminar flow, and the fluid motion that typically occurs at high velocities is characterized by velocity fluctuations are called as turbulent, and the flow that alternates between these two, that is laminar and turbulent, is called as transitional flow. The dimensionless number, that is Reynolds number, is the key parameter that determines whether the flow is laminar or turbulent. So this Reynolds number only decides the type of flow, that is laminar or turbulent flow, or if the flow is intermediate between the laminar and turbulent, called the transitional flow. It is also based on this Reynolds number. So this is called as laminar and turbulent flow. Then next type of flow is the steady and unsteady flow. So when there is no change in fluid property at any point with respect to time, then it is called as steady flow. So however, the fluid property at a point with respect to time, that is the flow is unsteady or transient. Then the term periodic refers to the kind of unsteady flow in which the flow oscillates about a steady mean. So this comes under the steady and unsteady flow. Then natural and forced flow. In a forced flow, the fluid is forced to flow over a surface by external means, that is such as pump or a fan. And in other case, that is considering the natural flow, the density difference is the driving factor of the fluid flow. So here the buoyancy plays an important role when considering the natural flow. So for example, a warmer fluid rises in a container due to density difference. This is called as natural and forced flow. Then coming to the next type of fluid flow, which is 1, 2 and 3-dimensional flow. A fluid flow is best characterized by the velocity distribution, and it can be treated as 1, 2 and 3-dimensional flow if the fluid property like velocity varies in the respective direction. So this is called as 1, 2 and 3-dimensional flow. Then next is the energy losses in pipes. So what is energy losses in pipes? When a fluid is flowing through a pipe, the fluid experiences some resistance. Due to this action, some of the energy of the fluid is lost. This is called as energy losses in pipes. So when a fluid is flowing through a pipe, the fluid experiences some resistance to the flow. So due to this action, there is some loss in the energy of the fluid, which is called as energy losses in the pipe. So the energy losses in pipes are classified into major energy loss and minor energy loss. So we can see the major energy loss and minor energy loss in detail. Major energy losses. So when the fluid flowing in the pipe is always subjected to resistance due to shear forces between the fluid particles and the boundary wall of the pipe and between the fluid particles themselves, results from the viscosity of the fluid. So this resistance of the flow, that is to the flow, is called as frictional resistance, and loss of head due to that is called as frictional losses. So the fluid flow which is subjected to resistance due to shear force between the fluid particles and the wall of the pipe, and also between the fluid particles themselves, which results due to the viscosity of the fluid. So this resistance to the flow of the fluid is called as the frictional resistance, and loss of head due to this is called frictional losses. And this frictional losses depends upon the type of flow. It may be either laminar or turbulent. There are different laws of fluid friction for laminar flow and turbulent flow. So the frictional losses mainly depends upon the type of flow, whether it is laminar or turbulent. Then coming to laws of fluid friction. So laws of fluid friction for laminar flow. The frictional resistance in the laminar flow is proportional to the velocity of flow of the fluid, and it is independent of the pressure of the fluid, and it is proportional to the surface area in contact. And this frictional resistance in the laminar flow is independent of the nature of the surface in contact. Then according to laws of fluid friction for turbulent flow, the frictional resistance in case of turbulent flow is proportional to velocity and is independent of pressure of the fluid, and it is proportional to the density of the flowing fluid, and it is also proportional to the surface area in contact in case of turbulent flow. So based on the Reynolds number, we are classifying into laminar flow, then turbulent flow and transition flow. Reynolds number is a dimensionless number. Based on its value, we are classifying the flow of the fluid into laminar flow, transition flow and turbulent flow. So it is clearly given in the diagram. You can see the laminar boundary layer which is uniformly distributed, and you can see the turbulent boundary layer. So under the turbulent boundary layer you can see the laminar sublayer, and the change from the laminar to turbulent is the region called as the transition region. When the Reynolds number is less than 2000, the flow falls under the laminar flow. The flow of fluid is called as laminar flow. When the value of the Reynolds number is equal to or greater than 4000, then the flow of the fluid is called as turbulent flow. And when the Reynolds number value is between 2000 to 4000, it comes under, that is the flow of the fluid comes under transition flow. So based on the Reynolds number, we are classifying the flow like laminar flow, turbulent flow and transition flow. Then coming to the minor energy loss, the minor losses of energy are those which are caused on account of the change in the velocity of the flowing fluid. The change may be either in magnitude or direction, and minor losses are caused by certain local features or disturbance which may cause eddy formation. In case of long pipes, these losses are usually quite small as compared with the loss of energy due to friction, and hence it is called as minor losses. So these minor loss, that is, it can be neglected without serious error, but in short pipes these losses may overweigh in the friction loss. So minor losses of energy are those which are caused on account of change in velocity of the flowing fluid. The minor loss of energy which includes under the following cases, that is loss of head due to sudden enlargement. Then second case is loss of head due to sudden contraction. Then loss of head at the entrance of the pipe. Then loss of head which occurs at the exit of the pipe. Then loss of head due to an obstruction in the pipe. Then loss of head due to bend in the pipe. The last case is loss of head in various pipe fittings. So first loss, minor loss due to loss of head due to sudden enlargement. then loss of head due to sudden contraction, then loss of head at the entrance of pipe, then loss of head at the exit of pipe, then loss of head due to an obstruction, and loss of head due to bend in the pipe, and loss of head in various pipe fittings. Then loss of head due to sudden enlargement. So we can see the diagram. So here the energy lost is because of the turbulence generated when there is sudden enlargement in the fluid flow. So this amount of turbulence depends on the differences in pipe diameter. Here you can see the two sections, that is section 1 and 2. So diameter of the at the section 1 is denoted by D1 and the diameter at section 2 is denoted by D2. So D2 is larger than D1. So the fluid which is flowing in the pipe having diameter D1, which is traveling at velocity V1, when it enters the larger dia pipe, the turbulence is generated, which is shown in the diagram. So what is the formula used to calculate the head loss due to sudden enlargement? It is given by, head loss is given by HL. HL is equal to K into V square by 2G, where HL is the head loss of flow and K is the resistance coefficient and V is velocity of flow and G is gravitational force. And this coefficient K is calculated using this formula. That is 1 minus A1 by A2 the whole square, which is equal to 1 minus D1 by D2 the whole square to the power 2, where A is the area of the pipe at section, that is A1 means area of pipe at section 1 and A2 is area of pipe at section 2. Similarly, D1 diameter of pipe at section 1 and D2 diameter of pipe at section 2. Then sudden contraction. Decrease in pipe diameter, that is loss is related to the velocity in the smaller pipe. The loss is associated with the contraction of the flow and turbulence. And the section at which the flow is narrowest is called as vena contracta. So here at the section where the flow is narrowest, the velocity is maximum. Here the flow from the larger dia pipe, it enters the smaller dia pipe. So here diameter denoted by D1, larger diameter, and D2, smaller dia. So there is sudden contraction in the flow of the fluid. Then loss of head at the exit of the pipe. So this loss of the energy loss of head is due to velocity of liquid which is being dissipated at the outlet of the pipe, either in the form of a free jet. If outlet of the pipe is free jet means if the outlet of the pipe is free, or it is lost in the tank or reservoir if the pipe is connected to the tank. So here you can see the velocity is V1 and when it enters it is V2. So loss of the minor loss is expressed as HL and it is equal to V square by 2G. That is, V is velocity at the outlet of the pipe and HL is head loss and G is gravitational force. By substituting the values of V, velocity of flow at the outlet, then G, gravitational force, we can calculate the head loss in the pipe. Then loss of head due to bend in the pipe. When there is any bend in a pipe, the velocity of flow changes due to which the separation of the flow from the boundary takes place. There is also formation of eddies, which results in a loss of energy or head. This loss of head or energy are expressed as, that is, when the loss of head due to bend in the pipe is calculated, that is, the energy loss is calculated using this formula when there is a bend in the pipe. So HF is equal to K into V square by 2G, where HF is equal to head loss due to bend and capital V is equal to velocity of flow and K is equal to coefficient of bend. Then G, gravitational force. So here in the diagram you can see the bend in the pipe. So there is a separation. You can see the inner wall, near the inner wall the pressure is very low, and in the outer wall there is high pressure. So using this formula we can calculate the head loss due to bends in the pipe. Then loss of head in various pipe fittings. So loss of head in various pipe fittings like valves, coupling, elbow, etc. can be expressed as, that is HF is equal to KV square by 2G, where V is the velocity of flow of fluid in the pipe and K is the coefficient of pipe fitting. So with this, I finish off this topic. Thank you.